Hello, and welcome to the wonderful world of mathematics. It's your host, me, Miss B. Today we're going to discover how we derive the formulas for area of basic polygons. So what is area? The measure of the interior surface of a closed region or figure, or the amount of space inside the borders of a shape, okay? So when would we need to calculate area in the real world? One example is when you're seeding your lawn. You need to know how big your lawn is, how much area to cover with the seeds. The next is if you're going to do any kind of work in your house, fixing the floors, you're going to have to measure the area of the floors and the area of the tiles to know how many tiles to buy. Another is obviously painting. Area, how much wall space do you have so you know how many gallons of paint to buy. And last, what about fashion? When you're talking about how much material to buy, you're talking about square yardage. How much material do you need to make a dress or pants or a jacket? So here's your index card number 1. Area, the measure of the interior surface of a closed region or figure, or the amount of space inside the borders of a shape. We also say square units because you use squares, small squares, to cover area. Examples of area in the real world. How many square yards of fabric do you need to make curtains? To determine how much grass seed to buy, you need to know the square yardage of your lawn. And to determine how much paint to buy, you need to know the square feet of your walls. Here's an example. Mr. Vitale is redecorating his house. He is going to paint an accent wall. The accent wall is 8 feet by 15 feet. If the paint covers 87.5 square feet per quart, how many quarts does he need to buy? Assume only one coat of paint and cans are sold by the whole quart. Okay, so if you guys are ready, the first thing what we're going to need to do is change the 8 feet by 15 feet to square feet. All we have to do is multiply 8 times 15. All right, give you a second to multiply that. All right, you should have gotten 120. Sorry, I just ran to get my little calculator to make things go faster. So it's 120 square feet. Okay, so if 87.5 square feet is for 1 quart, how can we figure out how many quarts we need? If you said divide, you're right. 120 square feet, how many quarts do we need? If we know that 87.5 square feet is covered by 1 quart. So you could cross multiply or know that all you have to do is divide 120 divided by 87.5. And we'll get 1.37. So x is approximately 1.37. I'm sorry, I wrote equals 2 signs. Make sure you do squigglies because we kind of rounded. Now let's be careful. How many quarts does he need to buy? Assume he's only going to do 1 coat of paint and cans are sold by the whole quart. Now if you round this, it rounds to 1. But if he only gets 1 quart, he's not going to be able to fully paint his wall. He'll have bare spots on it, which is gross. So instead, we're going to buy 2 whole quarts. Easy peasy, lemon squeezy. All right, next, here we go. Now, I'm going to introduce you to some shapes I know, some polygons. Here's Mrs. Rectangle. She's a 4-sided polygon containing all right angles. Here she is. And to get the area, I know you know base times height, okay? We also have width times length, same thing. Height here, base here. So why does this work? I'll show you. The height of this rectangle is 1, 2, 3 squares, and the base of this rectangle is 1, 2, 3, 4, 5 squares. So if I wanted to see how many squares were inside, 3 is the height, 5 is the base. All I would have to do is 5 times 3, and I will get 15. Notice if we count the squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, it works. That's how many squares are inside the borders of the shape. That's what area is. How many squares do you have inside the borders of the shape? There are 15 square units. If I said it was feet, then I'd have 15 square feet. All right, next. A square. You should know that a square is just like a rectangle, except all the side lengths are equal. Okay, so again, we have a height and a base, and here's Mr. Square. Hello. All right, and this time, notice there's 3 high and 3 to the side. So here's what's interesting. We can still do 3 times 3. We can do base times height. Base times height. 3 times 3 is 9. It works. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 square units. But we have a different area formula for square that we can also use. Notice that because the base and the height are the exact same measure, we can use the exact same variable. We use the variable s for side. So instead of saying base times height, we can say side times side. And remember, 3 times 3, isn't that 3 squared? So side times side is side squared. So if you had a square that was 4 and 4, you would do 4 times 4 is 16. Or 4 squared is 16. Squares all over the place. Parallelogram. 4-sided polygon with opposite sides being parallel. All right, so that's a parallelogram. Well, now this guy's all slanty. So remember, height, we can't use height times base because this measurement here, this slanted one, is not the height. Height, or altitude, has to be drawn from the vertex perpendicular to the line containing the opposite side. What does that mean? That means basically it has to go straight up and down connecting to the base. So let's see what we could do. There's the height. Notice I made a line that goes straight down, forming a right angle with the base. So it makes like a T shape. All right, so then now we could do it. Base times height, not a big deal. Same thing as before. Excellent. Uh-oh. What about triangles? Hello, triangle. All right. How are we going to do this? We have a height times a base, but I know if I do height times base, I'll get a full-on rectangle. So let's see what I can do. Magical things are happening. Now, height times base will give me this humongous area. So all I have to do to just get this part is cut this rectangle in half. So that's all we have to do. We're going to do height times base. That'll give us this. Height times base gives you the full-on everything inside the rectangle. And we just cut it in half for the triangle. There you are. 1/2 base times height. That's where it comes from. All right, next. Triangle again. What are you doing here? You were there already. All right. Where's the height in this figure? So it's missing, right? Because again, we have slanted. So remember, a height has to be straight down, touching the base at a 90-degree angle. So let's see what we can do. All right, if we're going to do the height is going to be right here. Height. Now forgive me that it's not crazy. It has to touch the base. Now, it doesn't have to really touch the base. It just extends. You're just measuring from the tip all the way to the bottom. All right, so there's where the height is. All right, and again, we're going to do the same thing. That's ugly. That's better. Okay, and we've got a parallelogram. And you guys remember, a parallelogram is just height times base. So I could actually put the thing here. Looks just like a parallelogram. Hey, you come to the front, you. Order. Bring to front. There you go. All right, looks just like a parallelogram, except it's not a parallelogram. We want just the triangle. So first we do parallelogram, base times height, and then we cut it in half, and we get our triangle. All right, so even if you have a slanted triangle, it's the same thing, except you have to be very careful. The height and the base must form a perpendicular. They have to form a right angle. They have to be perpendicular to each other, all that good stuff. All right, what other shape is there? Trapezoids. All right, this is going to be crazy. All right, A trapezoid is a four-sided polygon with one pair of parallel sides, as you see here. We call those parallel sides the bases, okay? So these two that are not parallel, if we extend them, they'll actually meet. So see here, they'll crisscross. Those would not be the bases. The bases are the ones that form like choo-choo tracks. They're parallel. They never touch. They're straight, straight, straight. Okay. So now, how are we going to make this shape? Notice that all the tricks we are using is we're turning the shapes into other shapes. Do you have any idea how to turn this trapezoid into a shape we know? All right, think about it. Think about it. Watch what I'm going to do. Does this help? Still not a shape we know. So now some of you may say, oh, there's a triangle here and there's a triangle here, and then we could do this. But here's the problem. We won't know what this measurement is or this measurement is once we split it. So if you don't know what this side equals, how can you figure out a formula? We need to know what the sides are. So that's difficult. But we do know what the bases are, and we do know what the height is. So ready? Uh-oh. Is rotations happening up in here? Yeah, rotations. Oh, translation. And look at what I just formed. Look at here. We got a parallelogram again. All right, now this is tricky though, because what's going on? Well, here's what's going on. Here's base 1, whatever number it is, and here's base 2, whatever number it is. Base 1 is also over here, that length. Right, whatever number's there. And here's the height. So that would give us a humongous parallelogram. We do not want this humongous parallelogram. We just want the trapezoid. But all I have to do is cut it in half and I have a trapezoid. So the formula is, let's see if you guys can figure it out. If it's a parallelogram, we have to do height times base. But look at this base. This base is crazy. This is a humongous base. Did you figure it out? Let's put some numbers in to help you. Here's some numbers. I'll pretend that the height is 5. I'll say that this base is 7. This is not drawn to scale. I'm making numbers up. And this base is 15. Okay. Well, I know the height is 5. So that's easy. Height is 5. Times base. The base is this long thing here. So it's not 15. It's more than 15. It's 15 plus 7. Why plus 7? Because this side of the base is the top of this trapezoid, which was 7. It's base 2 and base 1 added together. So 15 plus 7 is my new base. 15 plus 7 is 22. 5 times 22, because base times height will give me the parallelogram, is 110. But I don't want the parallelogram. I just want the trapezoid. So I have to get rid of this part, which is half of the figure. So if I get rid of that part, I have to divide by 2. And if I do